faster. But this is a Fortune 200 company from US. These are the company numbers. And we have 7 segments. We are from polymers and fluids. We are mostly on structural adhesives and testing machines. This is our global footprint. And coming to structural adhesives, most of you have visited our stall. This is a polymer chemistry with methyl methacrylate. And these are this is the chemistry of the adhesive where we can bond composites, plastics, and metals. The chemistry is MMA. And this goes with what is made, so I'll skip much on this. We have some nanoparticles in it which give strength to the adhesive. This is the patented core shell technology, which helps us in going to all the fields of transportation. And this has a properties, mixed properties, all the good properties from all the other adhesives like epoxies, PU, silicones, and all that. So this gives us a very good adhesive strength, compressive strength, impact strength, and dynamic loading. This is the nanoparticle. It's a patented nanoparticle. It's called patented core shell technology, which is like a soft tennis ball. This is how it looks, a microscopic picture with core shells in the resin. This is like how it bonds. I mean, we can share you all this if it is required. We can have a Teams call. We don't have much of time on this to explain how it actually reacts with the surface you are bonding, be it composite, plastics, or metal. It solvates the surface and bond. So that is the strength of the adhesive here, unlike in other traditional adhesives. This is what Plexus can bond. That Plexus is the brand name of the ITW MMA chemistry. So it can bond all these crisscross, across. It can bond anything to anything. I mean, these are the advantages of using the MMA-based adhesives. Like I said, they have the advantages taken from different classical adhesives. You can see the green one is MMA, which has taken all the properties from all the adhesives. This is the fatigue data where it will withstand 1 crore cycles against even the soft elastomeric bonds. This is an advantage for all the dynamic loading, like transportation segment. These are the applications where we come across from different segments. These materials come in 50 ml cartridges, 400 ml, or a dispensing machine. It's a 2-component material. You have adhesive and activator. There is a mixer. The product comes out as a single bead. This is the applicator for holding the cartridges. And this is a dispensing machine for 5-gallon or 50-gallon machines. These were some of the applications. This was a car developed by one of the Indian car company. The body is all made up of CFRP, GRP, and CFRP. They used 2 adhesives to bond it. It was displayed in the Geneva Auto Show. This is the Gypsy. The rooftop composite was bonded by using, our adhesives for the army. These are all applications which go into bus bodies. We are working with some of them. These are all parts which go into trucks and bus bodies, including external and internal. We are working with all the Indian Railway, the new trains, and the metro systems worldwide. This is a global product and it's a 35-year-old product. These are some of the applications. Interiors of the trains, floorboards, sidewalls. And these are general applications like CT scan machines, the domes which are made in composite. There are some metal parts to be bonded. Swimming pools, boat building, stringers to the bottom on composite boat building, high-speed boats, the stringers, the deck and hull bonding. yachts, marine, bigger boats, because we have all composite boats, pools, car parts, not in India much, but the truck parts are made up of composites now. Tanks, big tanks made up composite, made in two halves and bonded. They're into wind energy, into the wind blades, lot of secondary parts bonding and other parts inside the blade. Nacelle covers, and this is an infrastructure. Sorry, I missed the last slides. This is actually a neutral material, like a Green Guard certified. There are no carcinogenic materials in it. And I'll hand it over to my colleague from the testing machines department.
Hi, I'm Chetan. I represent Instron. You might be using Instron systems all over, and we have one in this university also. I represent lab, and this lab is an Instron company. We have a lab in Bangalore. There's a range of products that you might be doing, starting from as low as 1 Newton. We make universal systems from 1 Newton to 200 tons. So we build in Bangalore and a couple of other places all across the world. And coming to lab, we have 50 plus UTMs for all the mechanical testing services. We offer for a wide range of industries of automotive, aerospace, energy, and various lots of carbon fiber composites or the glass fiber composites. And we test roughly around 2,000 coupons a year for the certification programs, even for aerospace and the wind industry. So, and we have been accredited for NABL, that is ISO 17025, ATCAP for aerospace. The standard test that we do a lot in our laboratory. So when I have to take notes from Dr. Anand, so he was emphasizing on data generation. So we come in picture. So if you want to run a fatigue data for months, we will be able to help you in all these characterization of the materials. Like a similar test, tensile bending. So now the new norm is testing at minus 100 degrees. So all the drone manufacturers are flying in above the sky. So minus 100 is becoming a norm. We can even test at minus 100 degrees Celsius. You can see a typical pre-preg failure. And again, the short beam strength or the adhesive strength and with the core compression. So we characterize lots of materials in the lab. And there's the fatigue curve we generate on a daily basis. So the typical core material evaluation for fully reversal cycles. Lots of fatigue data we generate, and this can be helpful to train the AI models going forward. From the carbon fiber matrix, we have been approved by Airbus for all the new C295 program. So we've been testing all the core the carbon matrix for all the aircraft and satellite programs now. Again, similar tests, the fastener pull through or the fill hole compression. So standard tests that we have been certified to do in our lab. And we do lots of non-contact type measurements also in the lab. Where the traditional strain measurement fails, we use the non-contact measurements. And we also have the structural testing facility, not only the coupons, we can also test the substructures and the components in the lab. Lots of EVs we have been testing in the lab these days. This is the latch durability and one of the front fork member of an automotive, and the motor durability. All this fatigue and fracture, we are expertise. Yeah, thank you. So let me know, we have a stall here. So if you have anything, you can talk more on. Thank you.
Thank you, Swarupji and Chetan, for informative information. Both of you, please come on the stage, please.